Welcome to the Deep Dive. This is where we take your curiosity, dig into the sources you've shared, and really pull out the fascinating insights.
Hmm,
And today, we're heading back in time, way back. We're looking at ancient food systems.
that's right. And exploring the lessons they might hold for us today.
We've got a great set of sources articles, some research papers, all diving into how people nourish themselves long before, supermarkets and factories.
And our mission really is to unpack that, to see what wisdom we might have lost, especially around things like resilience, managing nutrients smartly, and the cultural weight of food.
It really is a stark contrast, isn't it? You look around today, industrial agriculture, ultra-processed everything.
Yeah, it's easy to feel disconnected from where food actually comes from, how our ancestors survived and thrived.
And some researchers are asking, could this huge shift be linked to modern health problems, this idea of an evolutionary mismatch?
It's a compelling idea.
Hmm.
And tied into that is this concept of lost system memory.
System memory. What exactly does that mean in this context?
Well, it's more than just forgetting grandma's recipe. It's losing that deep generational knowledge, understanding the local ecology, knowing how and why certain foods were prepared certain ways.
Ah, okay. Like knowing which wild plants are safe or how long to soak something to make it edible.
Exactly, that kind of embedded practical wisdom. And losing it, well, that has real implications for food security, for adapting to change.
Right. Okay, so where should we start? These ancient systems must have had incredible ways to just keep food from spoiling.
Absolutely. Without refrigerators or chemical preservatives, they were masters of preservation, using the elements, using microbes.
Yeah.
It's pretty ingenious stuff.
Let's get into that. Maybe start high up. In the Andes, chuño.
Yes, chuño, a brilliant example from the Inca and pre-Inca cultures. They took perishable potatoes, even the bitter ones.
And turn them into something that could last for, what, years? Decades even?
Potentially, yes. And the process is all about that extreme highland climate, freezing nights, strong sun during the day.
So they'd spread them out, let them freeze solid overnight.
Mm-hmm.
Then the sun thaws and dries them. And then comes the really unique part: they'd tread on them.
Physically step on them.
Yeah, to squeeze out the water and help remove the skins. They'd repeat that freeze-thaw-tread cycle over and over.
Wow. And you mentioned different types. Black and white chuño?
Right. Chuño negro is the result of that basic process. But for tunta, or white chuño, there's an extra step. They soak the potatoes, often in cold running water, for quite a while.
And that soaking is important.
Crucial. It leaches out bitter compounds called glycoalkaloids, makes it safer and more palatable. So these glycoalkaloids, they're natural toxins the potato produces,
Exactly. They needed to get rid of them.
which makes the white chuño safer. Now, nutritionally, it's interesting. You lose water, so the carbs get concentrated.
Okay.
But you also lose some minerals: zinc, potassium, phosphorus, magnesium, though calcium might actually go up in the white chuño, maybe from the minerals in the soaking water. Iron's a bit variable.
But the main win is that shelf life, just
Yeah.
incredible stability. Absolutely. It provided resilience in a tough environment, let them use diverse potato types, support big populations, even armies.
It's a perfect example of really working with the specific environment, isn't it?
Totally. Leveraging those natural conditions for long-term food security.
Okay, let's swap climates completely. North Atlantic coast, Norway, the Vikings, and stockfish.
Ah, stockfish. Another classic. Here the key is lean Arctic cod or similar whitefish and the very specific weather of late winter, early spring.
What kind of weather are we talking about?
You need to be cold, near freezing, but also dry and windy with some sun. That specific mix lets the fish dry out slowly without actually rotting.
Right, so they'd gut them, maybe take the heads off.
Yep, tie them by the tails and hang them on huge wooden racks. They're called orgel, right out in the open air.
Just hanging there. For how long?
For about 3 months, typically. Then they'd move them indoors to mature for another, say, 4 to 12 months in dry, airy warehouses.
And that drying process does what, nutritionally?
It concentrates everything massively, especially the protein.
Hmm.
1 kilo of stockfish has the protein of about 5 kilos of fresh fish.
Wow, that's efficient.
Hugely. Plus, it's a good source of B vitamins, iron, calcium, and again, that amazing shelf life years. And it's light, easy to carry.
Perfect for long sea voyages.
Exactly. It fueled Viking expansion, but it also became a massive trade good later on, a huge export, particularly through networks like the Hanseatic League.
So again, it's about cleverly using the local environment on a large scale.
Absolutely. Tuning a local resource into a cornerstone of their economy and survival.
Okay, from cold seas to the plains of North America, Pemmican. This sounds like the ultimate survival food.
It really was. Essential for many indigenous groups, especially nomadic ones. It's super concentrated, incredibly durable, made from dried lean meat, rendered fat, and often berries.
How do they actually make it? Sounds complex.
Well, you start with very lean meat, bison, elk, deer, whatever was available. Cut thin, dried completely over a fire in the sun until brittle. Then you pound that dried meat into almost a powder. Separately, render animal fat, melt it down, purify it, then mix that hot liquid fat really well with the meat powder.
And the berries.
Yeah, often dried, crushed berries like Saskatoons or choke cherries got mixed in, sometimes even honey. Adds nutrients, flavor, maybe some preservative effect too.
And then packed somehow.
Right, packed tightly into rawhide bags, parfleches. When it cools, the fat solidifies and creates this airtight seal. Very low moisture, protected by fat. That's the key to its longevity.
And nutritionally, sounds like a powerhouse.
Totally. High calorie, high protein, high fat, often called a complete food. Good iron, zinc, B vitamins from the meat, plus vitamin C and antioxidants if berries were included.
It lasted for months. Years.
Reports vary, but certainly months, likely years, potentially even longer under the right conditions. Essential for travel, winter survival, trade. European explorers quickly saw its value, too.
What strikes me here is the intuitive understanding of food science. Dehydration, using fat as a preservative seal, nutrient synergy. It's brilliant.
It absolutely is. A deep, practical knowledge. And speaking of preservation using smoke,
Yeah.
that's another ancient global technique.
Right, smoking. We think of flavor, but it's a preservative too. How does that work?
It's got two main things going on. One is drying the heat helps remove moisture. But the smoke itself contains chemicals.
Chemicals.
Yeah, things like phenols, aldehydes. They actually kill microbes and act as antioxidants. So they slow down spoilage and rancidity.
Interesting. So it inhibits microbes and stops fats going bad?
In part, yes. And the type of wood really matters. Hardwoods, hickory, oak, alder, generally give a better flavor and cleaner smoke. Softwoods can make things taste, well, resinous or bitter.
And there's cold smoking and hot smoking. What's the difference?
Big difference. Cold smoking is done at low temperatures, maybe below 30 degrees C or 85 degrees Fahrenheit. It's more about flavor and longer-term preservation, often used on foods that are already cured, like salmon.
Okay.
Hot smoking is done at higher temperatures, so it actually cooks the food while smoking it. It's a faster process. Preservation isn't usually as long-term.
Are there downsides, nutritionally or otherwise?
Well, heat can destroy some water-soluble vitamins like B vitamins and C. And there is a concern, especially with heavy smoking, about forming PAH, polycyclic aromatic hydrocarbons. Some of those can be carcinogenic.
Ah, right. PAHs. Something to be aware of.
Definitely. But historically, smoking was absolutely vital. Preserving meat and fish when you had a glut, getting you through the lean times, it was indispensable.
Incredible resourcefulness. Okay, we've talked elements, sun, wind, cold, smoke. What about the invisible helpers? Microbes, fermentation.
Ah, yes, fermentation. Found everywhere, ancient practice. Basically, you're letting microbes, bacteria, yeasts transform carbs, sometimes proteins, in food.
And they produce acids or alcohol.
Exactly. And those act as natural preservatives.
Ah.
But it's so much more than just preservation.
Right, I was going to say, there are other benefits.
Huge benefits. Enhanced nutrition, making vitamins, making minerals more available, probiotics, the good gut bugs, unique flavors and textures. And now we're learning about postbiotics too, the beneficial compounds the microbes produce. It's like pre-digestion, nutrient boosting, all in one.
So different from our often sterile modern food processing.
Very different. It's working with microbes, not just trying to eliminate them.
Let's look at specifics. Kimchi and sauerkraut, they're pretty famous examples of lactofermentation.
Perfect examples. Lactic acid bacteria, or L-lab, are the stars here. They eat the sugars in the cabbage or other vegetables and produce lactic acid.
And that acid is the preservative.
Yep, makes the environment too acidic for most spoilage microbes. You just need veg and salt, basically. The salt draws out water to make brine, which helps the L-lab get going.
And kimchi has all sorts of other spices and ingredients, too.
Right, making it even more nutrient-dense. Both are packed with vitamins, minerals, fiber, plus the probiotics and improved digestibility. Sometimes fermentation even reduces anti-nutrients in the veg.
Okay, what about bread? Sourdough's a fermentation thing too, right? But different microbes.
Exactly. Sourdough uses a symbiotic culture of wild yeasts and lactic acid bacteria. You keep it alive in a starter.
And that long, slow fermentation, what does that do?
Several things. It starts breaking down carbohydrates and proteins, including gluten, which some people find makes it easier to digest. It often gives the bread a lower glycemic index.
Meaning it doesn't spike your blood sugar as much?
Correct. And those LEVs are great at breaking down phytic acid.
Ah, phytic acid again. The stuff in grains that blocks mineral absorption.
That's the one. So sourdough fermentation can make minerals like iron and zinc more available from the grain. Plus, the acidity helps preserve the bread naturally.
Fascinating. What about fermented drinks? Kvass? Arag?
Yeah, common across many cultures.
Mm.
Kvass from Eastern Europe, traditionally made from fermented stale rye bread, sometimes beets, usually low alcohol, tangy, probiotic rich. Beet kvass was even seen as a liver tonic.
And arag? Mongolian fermented horse milk.
Horse milk, yeah. Fermented by wild yeasts and bacteria. It's slightly alcoholic, tangy, fizzy. The fermentation breaks down a lot of the lactose, making it easier to digest for many. Plus, you get the nutrients from the milk and the benefits of fermentation.
And then there's that Roman fish sauce. Garum. Sounds intense.
Oh, it was. A staple flavoring in Roman cuisine, made by layering small fish or fish guts with lots of salt, then letting it sit in the sun to ferment for months.
So the fish basically liquefies.
Pretty much. Enzymes from the fish, plus salt-tolerant microbes, break down the proteins into amino acids. Loads of glutamate, which gives that deep, savory, umami taste. They had different grades, used it in everything.
Now, with all this fermentation, you mentioned beneficial microbes, but what about things like histamine, biogenic amines?
That's a really important point. Fermentation can produce biogenic amines like histamine and tyramine. For most people, it's fine. Our bodies handle them.
But some people are sensitive. Histamine intolerance.
Exactly. They can react badly. So how did ancient cultures manage this without lab tests? Probably through trial and error, empirical knowledge.
Like using really fresh ingredients, controlling temperature, salt levels.
Probably all of the above.
Mm.
Maybe certain starter cultures they favored produced fewer amines. Sanitation, pH control. They developed practices that implicitly kept things safe. The fact these foods were eaten safely for millennia suggests they figured it out.
So microbes were allies, but needed careful management. Okay, beyond preservation itself, what about just long-term storage, keeping the harvest safe?
Absolutely vital. Root cellars are a classic example.
Right, those cool, dark underground places, what makes them work?
Key things. Cool, stable temperature slows spoilage. High humidity stops things like potatoes or carrots shriveling.
Good.
Ventilation removes gases, prevents mold.
Yeah.
And darkness stops potatoes sprouting.
And they could store quite a variety of things.
Oh, yeah. Root veg, squash, cabbage, apples. Sometimes different chambers for different humidity needs. Simple tech, very effective.
And for grains, granaries.
Yep. Had to protect grain from moisture, which causes mold and sprouting and pests, like insects and rodents.
So granaries were often built up off the ground, tightly sealed.
Often, yes. Using materials pests didn't like. If the grain was properly dried first, it could last for years in a good granary. Essential for civilizations based on agriculture.
What about food pits? Literally burying food.
Sounds basic, but it worked. Offered stable underground temps, protection from oxygen if sealed well, and concealment from pests or even enemies.
Where do we see evidence of those?
All over. Jomon period Japan, Iron Age Britain, Maori Rua in New Zealand. Used for storing nuts, grains, tubers. Often lined with bark or leaves, sealed with earth.
And simpler methods like just drying racks?
Still important. For fruits, veg, herbs, and meat strips, just needed good air circulation, kept off the ground to avoid contamination. Reduces water activity so microbes can't grow. Basic, but effective.
And we can't forget salting and curing.
Absolutely fundamental for meat and fish. Salt pulls water out by osmosis, and the high salt concentration kills or inhibits most microbes. Allowed long-term storage of vital protein sources.
It's just amazing, the sheer range of techniques. The sources had a table summarizing them, didn't they? Showing the mechanism, examples, nutrient impacts.
Yeah, it really drives home the point. It wasn't just about stopping rot. It was sophisticated management of resources for long-term nutritional security.
Right. Okay, let's shift from how they preserved food to what they've eaten. Let's take a culinary tour, starting with the Mongols on the steppe.
A fascinating case study in adaptation. Their whole nomadic culture revolved around their livestock, horses, cattle, sheep, goats, camels. So their diet was heavily based on animal products.
Meat was key, especially mutton, and using the whole animal.
Definitely. Fat was crucial for energy in that cold climate. Organ meats, marrow, nothing wasted. And dairy was just as important. Milk from all 5 species, but especially mare's milk.
Which they fermented into arag.
Right. easier to digest, probiotic rich. They also made a rule those super hard dried curds that last forever, and cheese, biaslag, and urim, a high-fat clotted cream.
And plants? Not so much.
Very little given the environment. Some foraging, but minimal compared to animal foods. Their preservation focused on freezing in winter, drying meat, even that unique method of tenderizing meat under the saddle.
It really shows how effective an animal-focused diet can be in certain extreme environments.
Absolutely. It provided the energy and nutrients they needed.
Okay, let's travel now to the Pacific Islands. Totally different environment bounty from land and sea.
Exactly. Sophisticated horticulture combined with expert use of marine resources. Staple starches like taro, yams, breadfruit, cassava, sweet potato, bananas.
What a variety there.
Huge variety. Plus all kinds of seafood, some domesticated pigs and chickens, maybe hunted animals. And the coconut, incredibly important for food, drink, oil, materials.
You mentioned taro. I remember reading it needs careful processing.
Yes, absolutely critical. Raw taro contains calcium oxalate crystals, tiny needles that are intensely irritating.
Ouch. So how did they deal with that?
Thorough cooking is key. Boiling, baking, steaming breaks them down. Peeling, washing, sometimes soaking also helps. And traditional knowledge with spot-on lab studies confirm these methods drastically reduce the oxalates.
And poi, the famous Hawaiian dish from taro. That involves fermentation sometimes too.
Often, yes. After cooking and pounding the taro into a paste, it's frequently left to ferment for a bit. Adds flavor, aids preservation, probably enhances digestibility. They also preserve breadfruit by fermenting it in pits.
It shows such a deep understanding of their plant resources and how to make them safe and nutritious.
Definitely. Resource management and food processing know-how were essential.
Now let's head to West Africa, another area of incredible diversity.
Immense diversity. Indigenous grains like sorghum, millet, fonio, African rice, legumes, vegetables, wild greens, and vital root crops, yams and cassava, plus sophisticated processing.
Cassava, again, that needs careful handling for cyanide compounds, right?
Exactly. Cyanogenic glycosides. Traditional methods are multi-step. Peeling, grating, soaking, fermenting, like for making gari or lafun, pressing out liquid, roasting or drying. Often several steps combined. Extremely effective detoxification.
And yams, too. They need processing.
Yes, methods like soaking, boiling, roasting, sometimes germination or fermentation reduce bitterness and anti-nutrients like phytates and tannins. There's evidence they even combine germination and fermentation. Very clever.
And fermentation seems like a real cornerstone there, too.
Huge. Fermenting grains for porridges and drinks, ogi, uji, akasa, improves digestibility, nutrient availability, adds probiotics, helps manage blood sugar, even diarrhea, fermenting cassava for gari, even fermenting palm sap for palm wine.
Plus animal products in stews and sauces.
Right. It's a picture of adapting to many different ecological zones using a deep, practical knowledge of food chemistry and microbiology, passed down through generations.
Amazing traditions. Now, stepping back even further, the Neolithic transition, the shift to farming. We often see it as pure progress, but the sources suggest it was more complicated.
Oh, definitely a double-edged plow, as they say. Yes, farming supported larger, settled populations. But often, the diet became less diverse than hunter-gatherer diets, more reliant on a few staple crops, like cereals and legumes.
And that had health impacts. What does the skeletal record show?
Some interesting and sometimes negative trends. In many early farming populations, we see average stature decrease. Dental cavities increase dramatically with more carbs from grains.
Right.
And conditions potentially linked to nutrient deficiencies like iron deficiency anemia, things like parodic hyperestosis, seem to become more common, though the causes are complex and debated. Plus, living closer together with animals likely increase infectious diseases.
And those early crops, grains and legumes, they have anti-nutrients.
They do. Phytic acid, lectins, protease inhibitors, tannins, oxalates, compounds that can interfere with nutrient absorption or digestion.
But Neolithic people didn't just eat them raw, right?
Yeah.
They developed ways to deal with these.
Absolutely crucial point. They developed processing techniques. Grinding, soaking, sprouting, fermentation, cooking. We find the tools, we find charred remains showing they knew how to prepare these foods to make them safer and more nutritious.
So the Neolithic wasn't just about new foods, but new ways of preparing food.
Exactly. It was a technological package deal. There's even a table in the sources summarizing those health and diet shifts during the transition. Really highlights the trade-offs.
That preparation aspect is so key. Okay, so these were sophisticated, resilient systems. Why did many of them eventually collapse or get replaced?
The tangled story. Empire building, industrialization, These were major forces for change, often leading to centralization and homogenization.
How did empires disrupt things?
Well, they often imposed new farming systems, prioritizing cash crops or certain staples to feed cities or armies, disrupting local, diverse food traditions. Then industrialization came along.
The drive for efficiency, monocultures.
Right. Think Green Revolution, higher yields of fewer crops. Mass production of processed foods became possible, and with better transport and new preservation tech, these factory foods could spread everywhere.
Often pushing out local, traditional foods.
Exactly. And these industrial foods often had, well, a less ideal nutritional profile. High in refined carbs, unhealthy fats, salt, additives, low in micronutrients and fiber. It eroded local control, increased dependence on outside inputs, and led to a massive loss of food diversity and knowledge.
Then there's ecological stress, climate change, resource depletion. These have always been threats.
Always. Even resilient systems can break under prolonged stress. Climate shifts have repeatedly disrupted food production throughout history.
Like the Great Famine in 14th century Europe, linked to the Little Ice Age.
Yes, widespread crop failures, starvation, disease. Or the Late Bronze Age collapse around 1200 BCE in the Mediterranean linked to severe, prolonged drought. Famine, societal breakdown, migrations. Egyptian records even talk about food aid for neighbors.
And climate change affects growing seasons, water yields.
Precisely. And when you add resource depletion, degraded soil, deforestation, overfishing, it makes systems even more vulnerable. It shows how tightly food security, climate, and society are linked.
And for indigenous people specifically, colonization was a major, often deliberate disruptor.
A primary driver, unfortunately. Colonial policies actively dismantled indigenous food systems worldwide.
How so?
Land theft, cutting people off from traditional hunting, fishing, gathering areas, restrictions or bans on traditional harvesting methods, forced assimilation, discouraging traditional foods, language, imposing European farming, pushing people into wage labor.
And promoting processed, often unhealthy, imported foods.
Often, yes. Cheap rations subsidize goods that replace traditional diets. The health impacts have been devastating: high rates of diabetes, heart disease, other chronic illnesses in many communities.
It really underscores the importance of indigenous food sovereignty.
Absolutely. The right to define their own food systems, control resources, access healthy, culturally relevant food. Because the destruction wasn't just about diet. It was an attack on culture, spirituality, knowledge, language, social bonds, everything connected to food.
But there are movements now to reclaim that sovereignty.
Yes. Powerful revitalization efforts happening globally. People are working hard to restore traditional foodways, like the examples from Wisconsin Native Nations mentioned in our sources.
It's clear the loss was profound. So, looking forward, how do we learn from this? How can ancient wisdom help build more resilient food futures?
There's so much we can draw on. The key lesson is resilience through diversity and decentralization.
Like the variety of crops in the Pacific or West Africa.
Exactly. That agrobiodiversity was insurance against failure. Compare that to modern monocultures, so vulnerable to pests or climate shifts. And traditional systems were often decentralized, community-based. Food sovereignty was inherent.
So the lesson is, promote diversity, support local food networks, empower communities.
That's a big part of it. And related to that is preserving or reviving that system memory.
That intergenerational knowledge again.
Yeah. Knowing which potato variety works best for chuño, how long to soak it, which wood to use for smoking fish. It's context-specific, practical wisdom passed down through doing, through stories.
And losing it makes it hard to just restart these practices.
Very hard. Revitalization isn't just about finding recipes. It's about understanding the ecological logic, the nutritional reasons, the cultural meaning behind them.
What about nutrient retention and dealing with those anti-nutrients? How did traditional methods compare to modern processing?
Traditional processing often hit a sweet spot, preserving food while enhancing nutrition and safety. We talked about reducing anti-nutrients through soaking, sprouting, fermenting, cooking. And nutrient retention varied. Drying concentrates things, but you lose some vitamins. Freeze-drying like chuño is maybe better for that. Smoking keeps protein fat, but vitamins can decline, plus the pH issue. Fermentation can actually create vitamins, boost mineral availability, add probiotics. Salting is pretty good for nutrient retention if you rehydrate properly.
And modern ultraprocessing often prioritizes shelf life or cost over nutrients.
Often, yes. Think of white flour stripping away the bran and germ removes so much fiber and micronutrients. Traditional methods were generally geared towards maximizing the nutritional value you could safely get from your available resources.
So how does all this ancient knowledge challenge our modern ideas about the ideal diet?
It pushes us to be more flexible, more context-aware. Look at those successful animal-heavy diets. Mongols, Vikings with stockfish, pemmican users, they thrived in specific environments where plant foods were scarce or unreliable.
So it challenges the idea that one single dietary pattern, like purely plant-based, is universally optimal.
It certainly shows that humans have successfully adapted to very different dietary patterns. Even in farming societies, animal foods were often crucial seafood for Pacific Islanders, fish and fowl in West Africa. It suggests we should move beyond rigid dietary dogma and recognize diversity.
And it hammers home the importance of preparation, right?
Absolutely critical. It wasn't just what they ate, but how they prepared it, reducing anti-nutrients, ensuring fermentation safety through practice, improving digestibility. Sourdough, chuño, properly processed cassava preparation was the technology.
And now we have nutrigenomics starting to explain some of the individual differences in how we respond to food.
Exactly. It's the interaction between our genes and nutrition. We have genetic adaptations from our ancestors' diets like lactase persistence or genes related to starch digestion.
And the mismatch idea is that our modern diets don't align well with those adapted genes.
That's the hypothesis, that the rise in chronic diseases is partly because our genes expect ancestral foods and we're feeding them ultra-processed stuff. Even the Neolithic health shifts could be seen as an earlier mismatch.
And nutrigenomics looks at specific gene variations, SNPs, that affect how we handle fats, carbs, vitamins.
Right. Variations in genes like APOE, MTHFR, FTO, histamine-related genes, they can influence individual responses. Plus, epigenetics, how diet can switch genes on or off. And the gut microbiome interacts with both our genes and our diet. It's complex, but points towards more personalized nutrition, informed by our evolutionary history.
The sources had comparative tables, too, showing the different staples and processing across cultures, really highlighting that diversity and the importance of processing.
Yeah, reinforcing those key themes.
So wrapping this up, the big takeaway seems to be that these ancient food systems weren't primitive at all. They were full of ingenuity, resilience, deep ecological understanding.
Absolutely, and they offer incredibly valuable lessons for us now.
Lessons about diversity in food and preservation, the crucial role of traditional processing for nutrition and safety, and the fact that successful diets are context-dependent.
Right. It's not about going back wholesale, but selectively integrating that ancient wisdom with modern knowledge.
To build a food future that's more resilient, more sustainable, maybe more equitable too.
Which means focusing on things like agrobiodiversity, relearning processing skills, supporting food sovereignty, preserving that system memory, and definitely applying an evolutionary lens to nutrition, maybe even considering those gene-diet interactions.
Which leaves a final thought for you listening. We've journeyed through millennia of food wisdom. How might reconnecting with this heritage, even in small ways, inform your own food choices?
Yeah, think about it. Is there one specific ancient technique or maybe a dietary principle we discussed that really resonated with you? Could you explore that, adapt it somehow for today? It's about cultivating a deeper, more mindful relationship with our food, informed by the incredible knowledge of those who came before us.